welcome to TS classes. In the last video, we have studied about the first order system, and today we will start the second order system. Okay, let's start the topic. This is a transfer function model for a second order system. Here, input is R of S, output is C of S. The gain here is omega n square divided by S whole into S plus zeta n, and unit feedback. That means the feedback is 1. In this transfer function, first we have to find what is the transfer function. So what is T of S? We know that the formula for T of S is equal to G of S divided by 1 plus G of S into H of S. The basic transfer function for the second order system, that is omega n square whole divided by S square plus 2 zeta omega n plus omega n square. This is the basic structure transfer function for this second order system. Here some basic terms are there, that is omega and zeta. We know that omega n is the angular frequency. Omega n is the angular frequency. Then zeta is the damping ratio. Zeta is damping ratio. So depending on the value of zeta, the damping nature of the transfer function or the model is changed. So the zeta value changes from 0 to some value. If this zeta value is equal to 0, if zeta is equal to 0, then the system is known as undamped system. Undamped system. Okay, if zeta is equal to 0, then it is undamped system. If the value of zeta varies from 0 to 1, if 0 less than zeta less than 1, then it is known as underdamped system. Zeta value from 0 to 1, that is underdamped system. If the value of zeta is equal to 1, if zeta is equal to 1, then it is critically damped. Critically damped system. If this value is greater than 1, then it is overdamped system. If zeta is greater than 1, then it is overdamped system. Okay, now we will study what is this damping ratio. Damping ratio zeta is the ratio between actual damping with respect to critical damping. This is the basic part for a second order system. Here we have studied what is the transfer function for a second order system, that is equal to omega n square divided by S square plus 2 zeta omega n plus omega n square. Next, what is omega n, what is zeta? Omega is the angular frequency and zeta is the damping ratio, and the value of damping ratio is the ratio between the actual damping with respect to critical damping. If this value is equal to 1, that is undamped. If this value varies from 0 to 1, then it is underdamped. If the value is equal to 1, critically damped. If the value is greater than 1, it is overdamped system. Next, we will study what is the time response for this system. Now we will study the time response analysis for an undamped unit step input. Here we know that the transfer function for a second order system, that is T of S, which is equal to omega n square divided by S square plus 2 zeta omega n s plus omega n square. We will study for undamped and unit step input. If it is undamped system, then you will know that zeta value is equal to 1. So for undamped system, zeta is equal to 0. So zeta is equal to 0. That implies what is the value of Ts will be here. So T of S is equal to omega n square divided by S square plus here 0. So S square plus omega n square. It is the T of S. Now we know what is for input step input. Unit step input. Unit step input means R of T is equal to U of T, which is equal to 1. That implies R of S is equal to Laplace of R of T. which is equal to Laplace of 1, which is equal to 1 by s. Now, the transfer function. The formula for the transfer function is C of s divided by R of s, which is here omega n square divided by s square plus omega n square. Now R of s is 1 by s, so C of s is equal to R of s into omega n square divided by s square plus omega n square. By putting the value of R of s from this, here we can get 1 by s whole into omega n square divided by s square plus omega n square. Now we found that the value of C of s is equal to 1 by s into omega n square whole divided by s square plus omega n square. This is the value of C of s. But to simplify this, it is very critical. So we have to simplify this by the process of partial fraction. So by simplifying this, that is 1 by s into omega n square divided by s square plus omega n square is equal to a divided by s minus bs plus c divided by s square plus omega n square. Sorry, here it will be plus a by s plus bs plus c divided by s square plus omega n square. By making partial fraction, we can get it that the value of a will be 1, b value will be minus 1 and c is equal to 0. We can get these three value by using partial fraction here. So C of s will be 1 by s plus minus 1 into s plus 0 divided by s square plus omega n square. So we have to find the value of C of t, that is the inverse Laplace transform of C of s. So C of t is equal to Laplace inverse of C of s, which is equal to Laplace inverse of 1 by s plus minus s divided by s square plus omega n square. By simplifying, Laplace inverse of 1 by s minus Laplace inverse of s by s square plus omega n square, which is equal to Laplace inverse of 1 by s is equal to 1 minus Laplace inverse s divided by s square plus omega n square is equal to cos of omega n into t, which is the C of t. This is the output. Here we see that the output C of t is totally depend upon time, and so it is known as time domain analysis. And here the input is unit step input, that is u of t is equal to 1, and this is used only for when it is undamped, that is zeta is equal to 0. Okay, today's class is over. Thank you.